All right, so we're gonna use what you learned the previous 3 videos in here. Okay, this is probably the most important part of drawing resonance structures, and I can't stress enough how important the resonance structure is. We're gonna use a lot of resonance in the later chapter, yeah, especially when we try to explain the observation or do reaction. Okay. All right. So there are several resonance patterns that you should be familiar with. Yeah. So it will help you for, like later on. Okay. The first one, if you see a lone pair or double bond, so basically electrons adjacent to a carbocation, you can draw the resonance structures. Right. Let me explain real quick. So a carbocation, just remind you, has an empty p orbitals, and this empty p orbital can receive more electrons. Right. So lone pair, right, next to a carbocation got an empty p orbital. You can draw a resonance structure there. I mean, draw the curved arrow and get another resonance structures. A double bond, also an electron, adjacent to a carbocation, you can draw a resonance arrow. All right. Right down here, double bond and adjacent to a carbocation. So that's one. Once you draw one resonance structure, it creates another double bond next to a carbocation. So you can do one more time. Here we go. All right. Notice that there's a little detail here. I drew an arrow from a double bond to a bond, right? Double bond to a bond, not double bond to a charge. The charge is not an orbital. The orbital is on the carbon. Okay. Okay. All right. The next pattern is called allylic lone pair. Now we're going to use 2 arrows in here. What do we mean by allylic? Let me clarify the technical terms real quick. Okay. So 2 words for you. We're going to use that in chapter 4. The first word is vinylic position, which is the double bond at carbon, the carbon on the double bond. Okay, we call vinylic position, vinylic carbon. And then next to the vinylic position, that is allylic position. That's what we're going to talk about today. Okay, that's allylic carbon. All right. Let's check with me real quick. So if I am looking at that double bond, okay, where's vinylic position? On the double bond, yeah, that's these 2 carbons are vinylic positions, right? And where is the allylic position? Next to the vinylic position, which is just that, an sp3 carbon right there. Okay. All right, next one. If I looking at that double bond, so where is the vinylic position? These 2, okay, and then allylic position next to it. Here we go. These 2 are allylic position. All right. Allylic lone pair is delocalized. If you remember, we talked about like a couple videos before. A lone pair next to double bond is delocalized. Okay, same thing. That's the technical term of the lone pair next to double bond is allylic lone pair. Right. Allylic lone. If you see an allylic lone pair, you can draw 2. You will use 2 arrows to draw a resonance structure like that. All right. All right. Now look at the not double bond. A lone pair on the oxygen. This oxygen here. All right. That's also a allylic lone pair. One of them going to delocalize. The other one going to be localized. All right. So we can draw the arrow. Ta-da. Here we go. All right. So vinylic lone pair is localized. If you still remember the lone pair on the double bond, that's vinylic lone pair, right? Vinylic position. You can make this orbital parallel with the p orbitals on here. So vinylic lone pair is localized. Add some word. I mean, the same thing. We talked about this before. I just add technical term in it. Vinylic and allylic position. All right. So remember, so allylic lone pair is localized. Oops, say wrong. Allylic lone pair is delocalized. Okay. All right. All right. Let's try here. Locate the allylic lone pair and draw appropriate resonance structures. All right. The double bond right here. So we have these 2 vinylic and the allylic lone pairs right there. This allylic position right here. This guy doesn't have a lone pair. The nitrogen have 1 lone pair. So that's the allylic position. Okay. All right. Allylic lone pair is delocalized. You can draw the resonance arrow like that. Okay. The other one is not allylic lone pair. You can't draw anything. If you try to force drawing it, no, you can't. This carbon is over octet. See that? You can't not draw this lone pair come down to form double bond here either. Yep, that's not, it's over octet. Can't do that. That's that carbon there. All right. All right, what about this guy? So a lone pair next to or adjacent to a carbocation. Draw right there. That's one, and another one there. All right. We continued on this two more patterns on the next video.